So hi everyone, welcome back to my YouTube channel Fitness Freak Computer Geek. Last lecture I have given you some basic of functions. I have given you some analogy of function and some theoretical concept of function. Also I have shown you some practical implication of function, the concept of function applied in our programming. Okay. So this is the continuation of that theoretical lecture. In this lecture I will now provide you more detail on function. Okay. And after this lecture we will move into the coding part, okay, and there we will practice lots of codes, okay, till your concept becomes cemented in mind, okay. So without wasting any time, let's begin. Let's hop up to my power plan slide now. So let's see the point here. We will generally use parameter for a variable name named in a parenthesis list of a function. So what does this mean? It says suppose this is a function. Suppose this is a function, okay. Here two arguments have been passed. Suppose int a, int b, int a, int b, okay. So suppose this is a function. So this is suppose a function. You have some code here. So what does this line say? We will generally use parameter for a variable named in parenthesis list in a function. So you can see that whatever parenthesis list we use in a function, generally we use variable name there, okay. So what does this mean? This means that whatever parameter we passed in a parenthesis of a function, okay, suppose this is a parenthesis of a function, so whatever argument we pass, in most cases those are variables name only, okay. What does this mean? Means, yeah, you can argue that I can use anything in the parameter list, what I have shown you in the last lecture, that parameter list can be anything. So you can write, instead of this you can also use here int, suppose some function are there, okay, you can also use this thing also, the whatever value return must be cached by function, okay. So you can pass this also, and sometimes you can pass array also, you will see when we will go, or pass something else, okay, whatever you like, but most probably you pass only variable name, because it is easier to use variable name as compared to this complex expression, okay. We can pass pointer here when we will discuss the pointer, which is the most important topic of C programming. So you can use pointer here, suppose this is asterisk is symbol of pointer, so you can use that, or even any stick, but generally use variable name. And for this coding part also I will limit myself to only the variables name part, okay. I will not discuss this type. You can pass function within a function also, we will discuss it, and later I will give some example, okay. I can discuss this, but in pointer part we will discuss this part, okay. So hope you get that point, okay. So now moving on, an expression can so suppose follow return. So what does this mean? Means you have designed some function. So let me give you some insight of how function work, okay, then I will explain this part. So suppose this is a function int max. So it is integer type, return type at integer, means this function must return a value which is integer type. I have shown you about return, I have explained in the last lecture about return types, okay. So it's nothing but what function is going to return. Suppose this is our function, max function of two argument. Suppose we have to find the maximum of two number, okay. I'll just name it to two number. I will show you also design how to design our three variable function comparing three variables. Logic will be revenge, but I will explain you via function, okay, how it work in a function. So suppose there are two arguments, int a and int b, okay. So if there are code here, let me design our code. If a is greater than b, then you can use printf a here, or you can use return statement here. So this follow the return. Now onward I will discuss return statement, okay. It is also a part of control for statement return. It's directly come back from that function, okay. So return means whatever we are working in the function, some body of function, you by using return, it will just come out of the function, and it can return or it cannot return value according to the return type of function. Okay, so we can directly write here return. So instead of printing, I will also show you the difference. What is difference between printf and return? Okay, printf you can use anywhere, it is actually a function call, but return is a statement. Okay, so this is the basic difference. And also if you use printf there, then it might, and you didn't use the return statement in the function, and the function required return statement, as it is have some non-void return type. In this case it will show error, but if you use return in this case, show an error. And also in the case where you use void return type, in that case also you can directly use return here. Okay, so it will not show any error. Okay, hope you're getting it. Okay, hope you're getting it. The simplest way I can say, show you. Or else what you will do, if a is not greater than b, then what, b will be greater than a or not. Okay, so return b, so return b or return a. So you can see here I have used the return statement here. So what does this mean? This means that whenever the function end, it have return, notice the return type end. So whenever the function ended, suppose we encounter closes parenthesis, which will show the return of this function, end of the function block. So after the end of the function block, it just control will return this value. Okay, whatever you want to return. So whenever you call this function, suppose in main function, suppose this is main body, and you call somewhere here, okay, max, somewhere here max. Okay, suppose you call this with value 2,3. Okay, so whenever you call this function, okay, so it will take your control flow to here. Okay, it is, remember the function is also part of control flow. Okay, this is somewhat different control flow than the loops. In the loops we are only moving inside a block, which is the main function block, but in case of this function call, we move flow or control to any part of the program now. Okay, so earlier the control flow statement like if else were a part of only all single function, but they can now connect multi-function here. Okay, if you're getting it. So whenever you call this function inside a main function, okay, this is main function, we have called this function inside a main function. Okay, we can call inside a main function, you can call this function within other function also. So in this case I am showing you that we are calling the function from main function. So whenever the function is called from a main function, the control go back to the function declaration part, and there from declaration to definition. If declaration and definition are in the same part of a program, then it will go directly to the definition part, and here onward it will now execute this. Okay, control now from here, earlier control was here, and now control come back to here. Okay, in the function block, beginning of the function block, the function which are called. So it will execute the code now. So it will check that if a is greater than b, all the argument have been passed to this function. Okay, so a will have 2 and b will have 3. So firstly compare 2 is greater than 3, condition false, so it will not return a. So it will return else part, move to else part, and it will return b. So b is what, 3. So this function wanna return 3 variable, so it will have 3, and then control after executing this block. Okay, after executing this block, control will go from this block to this block. Okay, so now you can here you can see the control flow here. Firstly we move this function to this function, then we start executing the body of the function line by line. Then after the end of function, we terminate the function and return the value by relinquishing the control to the main function, to the function where the function which we are executing was being called. Okay, so what I said here, the control flow will go back to the original function where the function has been called. So you can see that there are two-way flow control is there. Okay, so one way is from when we come back here to this function and we execute line by line, then we, after returning the value, we again go back to the original function from where the function which we are executing was being called. Okay, so in this way it will work. Hope you get some idea about how this work actually. Okay, so I am here about to discuss with you about this part. Okay, in this section, the return statement. So this is return statement. You can use parenthesis here, okay, or you cannot, it is optional here. Remember that this is a statement. Okay, it is not function. Okay, statement only, you might not be seeing it. Okay, this is statement. let me write it here, statement. Okay, hope you are getting it. Okay, so now moving on. So you here you can see the syntax of return expression, which I have discussed earlier. Okay, here you can see that. Now let's see the point. The expression will be converted to return type of the function. Okay, I have told you that whatever we return the value, it is arbitrarily converted into float or the data float in double according to the data type, according to the return type of that function. Okay, so what does this point say? You might have understand it. Let's not take any risks. Some of the people might have not have understand this. Okay, so suppose we have function have return have float value here. Okay, float function called some xyz function are there. Okay, some argument list are there, a b something. So whenever you use return here, so whatever value you pass return, it will convert it according to this return type of this function. Okay, float is return type of this function, so whatever value you return to the function, it is directly converted into the return type of this function. Okay, hope you are getting it. And parentheses are most often around expression. Okay, if expression are too big, you can use parentheses, but this is only optional. Okay, but they are optional. You can see there, it is only optional. You can use parentheses here or you cannot. Okay, it is optional. Okay, so hope it is clear to you. Now moving on. So the return statement is the mechanism for returning a value from the called function to its caller. So we have seen this. I have explained you by example that return statement is the mechanism for returning a value from a called function to its caller. So from a called function, this is called and caller function. Okay, let me just give you some brief introduction here. So what does this mean? Means, so suppose this is if you use max here inside a main function. Okay, suppose you use this type. Okay, some value pass and use a semicolon here. This is known as caller function. Okay, this statement is calling of function, and this entire thing is known as caller function, along with no curly braces and no here, and as well as no return type here. It is a calling function. Okay, so this function call a function, so it is called as caller. If you call someone, then you remind as caller. In this way, this function calling something, so it is known as caller function. So what does statement say? Return statement is the mechanism for returning a value from the called function. So it will call a function. It is calling a function or not? Is calling a function something or not? Suppose this is calling a function. Okay, here is codes here, something int. Okay, so the return statement is the mechanism for returning a value from the called function to the caller. So this is what? This is known as calling function or caller function. Okay, calling function, it is calling the function or not, so it is known as caller. So someone who calls someone is known as caller. This is a caller function. Okay, caller function, and this is called function. Okay, hope you are getting it now. What is caller and called? Remember this terminology. Okay, don't get confused in it. Try to relate this terminology according to your taking example from a daily life. Analyze this way in this case here. Okay, so function which does not have any return type, as well as does not have any data type in parameter list, as well as it did not have any curly braces, so it is known as caller statement. So this function is known as caller function, and whenever function is called someone, that function is known as called function. Okay, so what does statement say? The return statement is the mechanism for returning a value from the called function to the caller function. Means what? Value has been returned from this called function to the caller function here. Okay, this is the way return work. Okay, hope it is clear to you now. Okay, if you have any doubt, it will be clear when I will move into the coding part, or still you will have some doubt, please ask me in the comment section. Okay, so now moving on. Function did not return a value. A return statement with no expression causes control but no useful value to be returned into the caller, and thus falling off the end of a function by reaching the terminating right braces, and the calling function can ignore a value returned by a function. What does this mean? A function might not return a value. Suppose in void function, void main function, which I was using, you have seen that I didn't use return statement there, so that function was returning nothing. As well as if you have any, suppose you have integer type data type used in a function and you call return statement without returning anything, it will just come out of the loop whenever it encountered the right parenthesis. Okay, hope you are getting it. So now moving on, it's very easy thing. Okay, now let me give you the distinction between declaration, definition and calling of a function, which some of you might be confused from my earlier lecture. Okay, I have explained you at the end of that lecture. Suppose if you have remained any doubt, please watch this thing again. Okay, I will be teaching and giving you the visualization here. Okay, through visualization we will understand it more. So suppose this is function. Okay, so suppose we take the example of something like max of AB. Okay, suppose we take example of max of AB. So it can be, so one form is, there can we take three forms here. Okay, 1 2 3, and first form is suppose declaration of function. So declaration of function means what? It does not contain any body, it will just contain the syntax of function along with semicolon there. Okay, let me show you. So you can see that it is nothing has changed here, just return type is there, and also these are some parameter passed. So it is not a declaration. Notice the semicolon here, end of the block. Okay, notice this thing, it is very important here, you must understand it here. Okay, itself. So this is not a declaration of function. Okay, you can see there are no use of curly braces there, or the no use of we are not excluding this part also. So it is a function declaration here. Okay, so one thing you understand it here, that C in C and in C++, okay, C++ follow the same rules also. Function declaration is optional. You can declare it, you cannot declare it. Suppose there are some rules you see that if you have to define a function after the main function, I have told you in lesson that function definition can be present anywhere. So if you have to define a function at the end of main function, to period to that you have to declare the function before the starting the main function. Okay, it is a rule here. Okay, so you have to follow this rule in both C and C++. In Java it's not required. Okay, so function declaration is somewhat it is somewhat you can say optional if you declare the function before the main function here. Okay, we generally, it is good practice to define a function before the main function, before calling that function. Okay, it will be easier to call that function what the function we have written, so it will be easy to write the calling part there. Okay, so it will be more tedious if you write the calling part first and then define the function at the end of the main block. Okay, so it is, you can do it, it's up to you, but it's not a good practice. Generally most coders do like that. So in this way the declaration become they are obsolete there. We didn't declare the function, we can directly write the definition. Okay, let me show you one variation of it. You can also write in this way. Okay, it is most widely used in generally C++, but in C we don't use it more, but you must know that. So we can ignore the parameter name here. Okay, the variable name here. Okay, you can directly just pass the return type of function here, means data type of the variable. Okay, we did not mention the variable name here. Okay, this is the part you can do it. This thing also in declaration, or in C++ this is widely in use. Okay, so in C most of the coders don't use it, but I have shown you that, you just keep it in your mind. Okay, hope you get it. Now moving on, now let's see the definition part, syntax of definition of a function. So here you can say definition part. So definition, you have already seen the definition syntax in earlier lecture. Okay, there you return type, function name, and the parameter list, and curly braces on, curly braces code, and write the code inside it. Okay, we can leave this code part behind. Okay, if you don't write it, it will not show any error. Okay, and you can also ignore this parameter list here. Okay, so now moving on, and you can also eliminate this thing to some extent. Okay, if you eliminate this thing, by default it will assume everything have return type at end value. Okay, hope you're getting it. Now let's see the calling part here. Calling part is most I can say minimized way of function writing function name. Okay, this is the function calling part. Notice that there is no use of return type here. Okay, no int are used, and also parameters data type is not mentioned here, and it will show error if you mention the data type here there. Okay, because why it's so that because of the case of formal argument and actual argument. They are formal argument and some are called actual argument. Actual argument are those argument which are actually used in the function. So in this part, int a and b are used in the function. So these are known as actual argument because these are actually used. So actual argument, actual, and these function are then passed to this definition part. Okay, a will pass to this and b will pass to this. So these are known as formal argument. Okay, just because you are formally defined this thing. Okay, these things don't exist in real world. In this value are only exist. Okay, we are just giving it as a formal argument to it first. Okay, hope you are getting it. We are providing an argument as a formal, in a formal way. Okay, this is actually formal argument. Okay, hope you are getting it. Formal argument. Okay, these are actual argument and these are formal argument. I will explain you more when I will go into the coding part. Okay, so I just give you a vague idea about it. You can understand in it. Some of you guys might have understand it here itself. Okay, some of you might have some doubt. Okay, so please rewind the lecture, watch one more time. So these are not a formal argument and these are not an actual argument. Okay, so now moving on. Notice the name of function here. I have tell you in previous lecture that name of function and definition of function name and declaration of function name must be coincide with each other. Okay, it might not be different in all the cases. Okay, it must be same name. Okay, otherwise the compiler will unreliable to identify what type of function you are calling and what is the definition you are written of that function. Okay, is the definition belong to that calling function or not? Okay, it will get confused. So please remember that always use the same name in definition, declaration and calling part of a function. Okay, so now moving on. Now we will see the working of function. Okay, I will just give you brief idea how the function work in our system. So I will not go much detail of that part. Okay, it is the part of operating system. When I will, if I get time and I will make lecture on operating system, I will teach you there. Okay, so for just now understand it. I am providing a vague idea. Okay, so now moving on. Okay. So now let's see working of function. So this is our main body. Okay, so suppose this is our main entire program here. Okay, this is our program. Suppose for example something demo.c. I have named this file demo.c. Suppose you have saved it. So suppose you now defined a function here. Okay, suppose this is a function sqrt function. You know, all of us know that sqrt means what? Finding the square root of function. Suppose the 144 number is given. If you apply this function, it will return 12. Okay, because 144 is a square of 12. Okay, hope you are getting it. Square root, it will find a square root of function. So this is a function here and this is our main function here. Okay, so in main function you can see here, in main function the function sqrt is been called. So whenever, if then after, this is the file demo.c, and whenever you will compile this file, it will convert it into compiled file, and then after compilation it will convert it into dot .o file. Okay, demo.o. So this is the executable file or object file, and this file is being, so let me just give you some brief detail here. If you don't get it here, okay, you don't need to get into detail, but it will be advantage if you know it here itself. Okay, because you have to know this. So curious person must listen to this thing very carefully. Okay, so what will happen now, whenever the object file is called, operating system create a new process. In that process or executable file will be there, that is object file, and whenever this process, it will place in a ready queue, and after placing it in a ready queue, it will move to the running queue. This is our processor. Whenever this is running part is our processor, whenever this executable file put into our processor, okay, it will start executing the file. So what will it do? It will first start read the file from starting. It will just include all the file, then it will search for main file. Okay, main function. Okay, main function in the program. After finding the main function, it will just allocate your memory according to your need. Okay, so it will allocate the memory in a stack. Okay, a stack data structure, which will learn. If I get time, if I make videos on data structure, I will teach you there. Okay, don't worry about it. So suppose this is the vague idea of stack. Whenever this function, this is placed in our processor, what will it do? It will provide space for our main function here. Okay, so main function space is provided, and whenever there is calling statement here, suppose like sqrt here. Okay, this part sqrt. So it will again create a new space in a stack for sqrt here. So in this way, generally whenever the process is created, okay, let me give some break id here. So whenever the process is created, my .o file, it will have consider generally of 2 to 3 part. Okay, we might not go into detail. So these are heap, some part is heap, okay, heap move upward, downward, and some part is stack. Okay, this is heap, this is stack. Okay, so go upward, and there is our demo file. Okay, demo.o object file. So this is our process. Okay, process is created, and if this under this demo file there are some function, the stack data structure has been allocated to this function call there. For function call we should use stack data structure here. Okay, hope you're getting it. So just remember this stack, I will teach you there in data structure section. Okay, if I get time to make the video. So stack, so this is data structure. So whenever the function is called, it will create new space and it will just execute the line of code, and then this will just terminate this function. Also this will pop out of this space. The space are relinquished now, and we come back to main function, and whenever the function is completed execution, it will free up the memory. Okay, so in this way it will work. Okay, so let me just give you in a animation way, it will provide you animated way of how this work, whatever I explained here. Okay, hope you get it. Please remind the lecture if you want to listen to my explanation again. Okay, then move up to the animation part, you will understand there more. Okay, so now let me show you that. So now the executable file is created. So what will happen? So main function, and the space will allocated. Okay, the space which I have shown you, this space will allocated in a stack part of the process, the process which I have shown you. If you forget it, let me show you the. So this is our process, suppose. So there are some part here, and this the object, our file is residing here. So this is stack. Actually this is stack. Okay, this part is space, some in memory allocated stack. So space has been allocated in our stack for function calling. Okay, suppose this is our main function calling, so space has been allocated. So what we'll see now, so these are some code, and suppose there are some function block here, these are some function calling block here. So what we'll do after, if you use this calling part, then again it will just it will just create a space for this function also, which I have shown you in the explanation there. Okay, so in space is created now. After that space creation, so everything will be executed. Okay, again now after that the function will relinquish this space, or free the space, and return back to original space, where it will execute the remaining part of the main function. If there are something here and some more calling are needed, then some more new memory will allocated there, and after that everything has completed in the main function, it will also relinquish that space, and our program has been executed. So these are all things are just happen in microsecond here. Okay, so you can understand, now you can understand what the power of the CPU or power of the computer which I have man-made. Okay, so this is very interesting thing to know. Okay, so if hope I had tried my best to make you clear this out. Okay, please watch this video 1 to 2 or more time, you will definitely understand this. Okay, just keep in your mind, just analyze this part. Okay, you will read more about it in operating system memory management part. Okay, so that's all for today. Thank you for watching. I hope whatever I explain here, you have understand it in very depth. Please revise this lecture, remind this lecture, and watch 2 to 3 times if you have any doubt. And in the next lecture we will see some coding example of function. Okay, there I will explain you the theoretical part which I have explained in this lecture. Okay, you will in that lecture you will get more insight of the function, how function really work. Okay, so thanks for watching, see you soon.